Hello and welcome to the fourth lecture in product modeling. Today we're going to talk about design automation and how it works when you're working in a group. So as stated in previous lectures, this is going to be the PowerPoint lecture is going to be combined with a hands-on lecture, and we're going to keep working on the aircraft model and the aircraft configurator that we have started to create in the previous lecture. Okay, and a summary from last lecture. So the task was to create an automatic procedure for adding and deleting ribs. And so here, as you could see, when we did the CAD model and the script, if the number of new ribs was greater than old number of ribs, then you go to a process where you first copy references, and then you go into a loop where you start adding the ribs. And adding the ribs consists of adding new part, changing the part name, and then you have copied references previously, and then you just paste them in the new part, instantiate your power copy, and then you modify the instance parameter. And this is basically the logic that you need to apply for any number of objects that you want to instantiate, whether it is ribs or windows or stanchions or whatever. If the old number of instances is greater, then it goes into a loop where it starts to delete the number of instances instead. And where we were left last time was that we created a product. In this product we had a wing which was instantiated, and then also we could instantiate ribs inside the wing, and then we could control the number of rib instances automatically with VB. So you need to know the purpose of your work, and that will affect how you will collaborate. And in this case, the purpose is design automation, and it's to automate repetitive and tedious design operations. And then the question becomes, what are tedious design operations? So the specific operations that we want to automate are morphological transformation and topological transformation. This can be viewed in a transformation matrix. So morphological transformation you can either you can do with relations, and relations can either be equations or script. And then you can have topological transformations where you can either perform it with activation states, which is script based, or you can do it with high-level CAD templates. High-level CAD templates is a generic term for power copy, but CATIA is not the only tool which can perform high-level CAD templates with power copy. You have the same feature in other CAD tools. You can make the same. You can have the same functionality in Creo and SolidWorks and NX and Inventor and also Onshape. Okay, so morphological transformation. The main operators are on part level. The intelligence is stored on part level. Morphological automation can be delegated to various team members. Each team member can be responsible for their specific part. topological transformation is a little bit more tricky than morphological transformation. You need to figure out in your group project, exactly what the model should be able to do, how many different power copy templates will you have in the end, which power copy template is most parent and which is most child. Delegate the power copy templates within the group. Okay, so here you're wondering, okay, what is he talking about, most parent and most child? What is that all about? Usually when you're working with power copy and they are instantiated within context, sometimes or more often they are instantiated upon each other as well. So power copy 1 is instantiated, and upon that power copy 2 instantiated, and then power copy 3 is instantiated on a power copy 2. So power copy 1 becomes most parent and power copy 3 becomes most child. You start with power copy 1. You finish with power copy 3. So in this situation, if you're dividing 3 different power copies within your group, the one who's working with power copy 1 needs to provide references for power copy 2, and the one working with power copy 2 needs to provide references for power copy 3. And here is where your collaboration method comes in play, because it's not only what type of references power copy 1 wants to give to power copy 2, the one who is working with power copy 2, that specific part that you're doing, you need to figure out, okay, so what type of references do I actually need in order to create my part? So there has to be a dialogue between the two who are doing these parts. And at the same time, if you have a third person who's doing the power copy 3, there needs to be a dialogue between power copy 2 and power copy 3 persons. So a lot of dialogue in order to make sure that you get all the references correct. And by reference, what I mean is, let's go back a little bit. So as you see in this picture, here we have external references. We have 2 surfaces, 1 line, 1 point, and 1 plane. So there is one time in the process where you realize, okay, so these are the references I need in order to create my power copy, my geometry, and be able to instantiate. And that is the knowledge that you need to come up with when you're discussing with your group members, and you'll be able to start modeling your power copies. So in order to create your power copy, you need references from the parent cat part, copy references to the child cat part. When all references are in place, the child cat part can now be delegated to a specific team member for build-up. Test each power copy as much as and as soon as you can. Do not invest in details to begin with. This is very important. Make sure that power copies work in the correct way early on. When you know that everything works, start investing time on details. So, power copies within the group. The references are established for each power copy and assigned to each member. Each member creates their own code to test their specific power copies. When the first draft of power copies are ready, then store in a common folder. All group members will have a copy of the power copies in own drive to keep improving and testing. So when you're going to write the code, these are the steps that are recommended. Decide what your automation process should do. Divide the code within the group. Implement in 1 to 3 days. Meet up, either physically or with teams, and see if original plan still holds. How complete is the code? Can it be tested? What is needed in order to connect all the dots? Are there any technical enablers which are still unclear? Redo previous until code can be tested. Code cleanup, redo all steps until complete project. So this is the process which we recommend for you to use. This is your method for collaboration, so to say. So if you don't agree with these steps, we recommend that you come up with your own steps that you follow when you're writing your code and you're doing your project. But this is what we normally do when we ourselves are in a similar project. So in the next video, what I will do is that I will start modeling the horizontal and vertical tails, the pylon and the nacelle for holding the engine in place, and then basically everything else which is needed. I'm going to reuse the same geometries for pylon, wing, horizontal and vertical tail. And then I'm going to use the same geometry for rib, stringer, structuring, wing, horizontal and vertical tail, and fuselage. So all the structures within wing, tail, and fuselage is going to be as few templates as possible. I'm going to create new geometries for nacelle and fuselage. The instantiation process is divided in two sections: configuration of the conceptual aircraft, and when that is done, instantiation of the actual structure. The user interface will be in Excel, if there is time. Let's see how that goes. So more of that in my next video. Thank you for watching. Bye.